my dear student, I'm Sakitwala from Educare TZ. I will be with you in physics for Form 5. And today we are going to proceed with our discussion here for our topic of circular motion, simple harmonic motion, and the gravitation. So today we should continue with our subtopic here, which is called the simple harmonic motion. But before we continue with our discussion, now we are supposed to remember what we tried to see on the last session. On the last session, my dear student, we tried to demonstrate the formula of obtaining the period when a test tube for a flattening test tube in a liquid. We try to say that this test tube, it means the period of fluctuation must be equal to 2 pi times the radical of height divided by g. And after there, we try to demonstrate the energy. We try to see the concept of the energy change in a simple harmonic motion. And we demonstrated the formula of obtaining the potential energy and also the kinetic energy. But now, my dear student, we should proceed with our discussion here on how we can demonstrate the formula of obtaining the total energy. How can we demonstrate the formula of obtaining the total energy? So welcome again for this discussion. So the total energy ET of the particle at any point in the sum of kinetic energy and the potential energy. As we know that the total energy, which is represented by symbol ET, this gives us the sum of the potential energy and also the kinetic energy. We should find the formula of the E total or the total energy by considering the potential energy and also the kinetic energy. So as we know that, how can we get this one? Let us recall the formula of the E total. E total must be equal to PE, where PE represented the potential energy, plus the KE. KE represented the kinetic energy. So after there, my dear student, we should take the formula of the potential energy and also the kinetic energy finally substitute into the E total, the total energy. If we substitute, we will replace that the potential energy must be equal to the half mw square times the displacement square. But the kinetic energy, as we have tried to demonstrate on the last session, we said that this must be equal to a half times the mass times the angular velocity square times the bracket, the amplitude square minus this displacement square. Here we was having the value of the v square velocity, where velocity we try to see on the circular motion. We say that the velocity must be equal to the angular velocity times the angular velocity times the square root of the amplitude square minus the displacement square. So finally here we are supposed to simplify. Now let us simplify this formula. How can we simplify? We are supposed to take it to open the bracket here. Let us take a half mw square and multiply inside here. So to open the bracket, we must multiply firstly with an amplitude, and after there we minus it by a half mw square times the displacement plus a half mw square times the displacement square. Now after simplifying it, my dear student, we should get that we should see that this a half mw square x square should be out with this a half mw square x square that are found here, because there is the negative sign here. Kwa huyu ataweza kuisha. And finally here we should the remaining one will be equals to half mw square amplitude square. Now we should obtain that the total energy must be equal to the half times the mass times the angular velocity square times the amplitude square. This A means the amplitude, my dear students. So therefore, after getting this formula, now we are supposed to conclude. And we should conclude by saying that this will be the formula of obtaining the total energy. This will be the formula that imply the total energy of the particle executing the simple harmonic. And we know that this particle executing the simple harmonic should be always a constant. Yule total energy anakuwa ni constant pale. So the variation of the total energy between the potential energy and the kinetic energy with displacement or with time shown in figure 3.27 here. Kwa sasa tunakuwa tunapata kumba how can we get the variation. Now we should you will be asked to use the diagram so as to demonstrate to show the total energy and also the kinetic energy, finally the potential energy. And we should use this figure here, that this figure should express how can we how can we sketch the diagram representing the total energy, and the diagram also representing the potential energy, also the diagram representing the kinetic energy. So we have our figure here. Our figure Romani, figure A, as we try to see. And this figure gives us the energy variation in a simple harmonic motion. How the energy vary in a simple harmonic motion. So as we observe here, that on this figure, the vertical one we should represent the energy, but the horizontal should represent the time. It means this is the curve that gives us the relationship between the energy and also the time. And we have said that the total energy when the body executed a simple harmonic motion always is constant. It means anakuwa anabini constant. So as we see here that we have this point O, and this point O represent the original position, and we tried to see that we have the energy, and some of the energy starting at the top here at the equilibrium position and become downward, and after they go at the equilibrium, then move downward. It means try to undergo the simple harmonic motion, because it move downward, upward, down and upward. They undergo the simple harmonic motion. But as we observe here, some of the energy should start at the certain amplitude or at a certain point, but amount of them should start at the equilibrium, at the original, as we observe here. That we see that this energy starting at the equilibrium position, it means at 0, at the original, and go upward, and then come downward, go upward and come downward. So once we try to see this figure, this dotted line here represents the sum of the kinetic energy, and here at this point this is the maximum amplitude, as we try to see here. Kwa huyu atakuwa dotted line, it means kwamba anamaanisha ile sum. Kwa ukiambiwa kusketch the graph that indicate the total energy, should indicate the energy at the vertical one and also the time at the horizontal one. But we should indicate this dotted line as the total energy. So after they are here, we were supposed to see that the energy that starts at the certain point then become downward and then move upward, then become downward, move upward. This we should call as the potential energy. Kwa hii ndo potential energy ambao huu mstari ambao tunauona wa sinusoid hapa ndo una represent the potential energy. It means that the point should start at the certain point, then become downward, and after there go upward, then come downward. That is how the energy can be propagated here at a certain time. But the dotted one which starting at the equilibrium position, ambayo inaanzia hapa kwenye original position, we see the particles rise and then fall down, then rise, then fall down. This should indicate the kinetic energy. Kwa hiyo ile pale itakuwa ni kinetic energy. So after there Now let us go and see another figure here. Let us go another and see the figure Romani B. So on our figure Romani B, my dear student, it is similar with that one, but this is involving more oscillation, kama tunavyoona hapa kwamba motion ya particles ilikuwa ni nyingi, lakini here we are going to see this simple diagram that you can use so as to indicate the figure that you should be asked. This gives us the variation between the energy and also the displacement. Kwa ukiambiwa kuchora kavu inayotupa uhusiano uliopo kati ya energy pamoja na time, you should sketch this figure number 3.27 Romani A. But if you will be asked to sketch the figure, the figure that give us the relationship between the energy and also the displacement, you should sketch this one. As we try to see, my dear student, that at the vertical line here we have the energy, but at the horizontal line we should allocate the displacement. As we see that this is the negative amplitude, but this will be the positive amplitude. All lie on the x-axis, as we try to observe here. We observe that we see the potential energy here becoming at rest. Kama tunavyoona potential energy dotted line yake ni hii hapa. It means kwamba ni kavu ambayo ina act kwenda juu. Ile kavu yetu ambayo inaangalia juu, ile ndio tunaita ni potential energy. Tunailabel ni kama potential energy. But the curve that act downward, this should be the kinetic energy. Kwa hii inayopanda juu, inayoform curve kwenda juu, hii tunaita ni kinetic, ni potential energy. Lakini inayoform curve kurudi chini tunaita ni potential energy, my dear student. Tunaita ni kinetic energy. But this one, as we try to see that this should be the maximum point. Hapa ndio itakuwa ni maximum point ya zile particles zetu. It means kwamba zikifika hapa hazitakuwa hapata kuwepo na ability ya energy yoyote kuweza kupandisha kupeleka chini. Kwa the curve that formed upward tunaita ni curve ya potential energy, lakini ile inayo act downward tutaita ni curve ya ile potential energy. Tutaita ni curve ya ile kinetic energy. So after there, my dear student, after looking at the curve for the energy against the time and also the energy against the displacement. Now let us go and see some examples related with what we try to see here. So our example say that, our example number 3.14, this is an example that we try to explain what we tried to learn here. Now we have a particle of mass 0.25 kilogram, and try to vibrate with a period of 2.0 seconds. If it is greatest displacement is 0.4 meter. Now what is the maximum kinetic energy? So welcome for this example here, my dear student, that we have the particle, and that particle containing the mass of m, which is equal to 0.25 kilogram. This try to vibrate, it vibrate at 2 seconds. It means iliform vibration ndani ya sekunde 2, lakini ilitengeneza displacement ambayo ilikuwa ni sawa na 0.4. This is the greatest displacement. Now how can we find the maximum velocity? So first of all, we are supposed to summarize the given values into our equation here. And on our equation we have the mass of the particle, which is equal to 0.25 kilogram. And if also we have the period, it means the period where the particle tried to vibrate, which is equal to 0.4 meter. And also we have the period is equal to 2.0 seconds, but the greatest displacement is equal to 0.4 meter. Now we are supposed to find the value of the maximum velocity, the maximum kinetic energy here. Now, from our formula here, as we try to observe, from our formula that we say that the kinetic energy must be equal to the half m w square bracket a square minus the x square. But on our formula, we tried to define each symbol here that m should represent the mass, but w square should represent the angular velocity square. And finally, A represents the amplitude. Also, X should represent the displacement as we try to see. Now, but our question need us to find the maximum velocity. How can we get the maximum velocity? But always the amplitude, the maximum, the greatest displacement should be equal to the amplitude. Now, how can we get the maximum kinetic energy? So, for the kinetic energy to be maximum, it means the displacement here must be equals to 0. Kwa ili huyu awe ni sawasawa na maximum, huyu ili tupate maximum hapa, maximum kinetic energy, basi we are supposed to take this displacement and equate equals to 0. Now, after equating equal to 0, if we take this 0 and substitute into the place where there is the displacement, we should obtain that the kinetic energy equals to the half m angular velocity square times the amplitude square at x is equal to 0. Now, after there, my dear student, what we are supposed to do after making the formula of the kinetic energy, which is equal to the half m w square times the amplitude square. Now, we are supposed to go and substitute our given values. So let us reflect for our question here and take the value that we have been given, then substitute into our formula. So for our example here, we was having the value of the mass. Now we have the value of mass, which is equal to 0.25. Now we should take a half times the mass, which is equal to 0.25. And finally, we are supposed to multiply by the angular velocity square. But we don't have the angular velocity. How can we get the angular velocity, my dear student? We are supposed to substitute the formula of the angular velocity, which is equal to 2 pi divided by the period. Kwa palipo na angular velocity square tutaweka ni 2 pi. Palipo na angular velocity itakuwa ni 2 pi divided by 2, ambao huyu 2 anamaanisha kwamba ni second, ule muda ambao tulikuwa tumeshapewa pale. So if we omit this one by taking it is a formula which is equal to 2 pi over t, but t we have which is equal to 2 seconds. Now paste it is a formula, and after there indicate the square, ambao pale kwenye angular velocity square kuna square pale, kwa tutasubstitute ile formula yake alafu tutaiplace ile square. Then after there we are supposed to multiply by 0.4 meter. Kwa baada hapo we should take the amplitude here, which we have been given into our question, which is equal to 0.4 meter. Now after there place it and omit the amplitude, then leave the square. Baada hapo sasa kinachofuatia ni kuweza kucalculate. So how can we calculate this one? You are supposed to use the mathematical calculator. I know that you have, my dear student, kwa sababu hicho sio kitu kigeni kwako. So how can we find it? There are two methods that we should use here so to find the value of the maximum kinetic energy. The first one, we should use the direct method. Direct method ikiwa inakuwaje kwamba we are supposed to take those value and place into the calculator. Kwa utachukua calculator yako, then you have to write the half au 0.5. Mwisho wa siku utazidisha na 0.25. You have to leave out the sign here kwa sababu haina umuhimu, haipo kwenye calculator pale. Then times by 2 pi divided by s. Hapo utaintroduce bracket kwenye calculator yako na mwisho wa siku utaingiza hizi value alafu utaweka ile square, and after there multiply by 0.4. So after there, my dear student, you should get the maximum kinetic energy, which is equal to 0.197 joule. na tunaona hapa jibu letu tumepata ni 0.19 joule. You have to write the SI unit kwa sababu kwenye physics kila jibu unalolipata lazima uweke kipimo chake, it means ile SI unit yake. So after getting the answer of the maximum kinetic energy, now we were supposed to conclude by saying that therefore the maximum kinetic energy is equal to 0.197 joule. Here I have forgotten to write the SI unit of the kinetic energy. Kwa hiyo nitakuwa utaongezea hapa itakuwa ni joule. So after there, my dear student, this is the end of our session here. Now I would like to welcome you again for another session. I wish you all the best.